Alright guys, welcome back. In this video I'm going to show you how to balance a chemical equation, and this time it's not going to be so pretty. We're going to run into a problem with polyatomic ions, and also I'm going to show you why it's also not so pretty on a matrices. Alright, let's go ahead and get started. Okay, first thing you want to do is when you're balancing these by hand is just like you did on the other ones, but you got to be careful. Sometimes you can treat a polyatomic ion, which is a group of atoms that's hanging out with a charge. But remember, in an ionic compound, you have a transfer of charges. Therefore, you have whole number ratios that's created from those. Now, if you notice here in this group of atoms, which I like to call a family, you can see a family here because it's got a nice set of parentheses showing you that this is a polyatomic ion. So anytime you see a group of atoms, think polyatomic ion. Okay. Here I see 3 nitrogens. I also see 12 hydrogens. But I also see 3 NH4s. Depending upon what kind of problem you're dealing with, you can do it that way. So what I'll do is I'll make sure that if I see NH4 here on the left, I'll look on the right and make sure I can see NH4 as well, and I do. And the PO4, I see one of those here, and I'll look over here and I see one of them over there as well. I know there's a 4 there, but just make sure that the polyatomic ions are there. And notice here I see PB, and over here I see PB. Yeah, there's a 3 there, but that's okay. And here I see a group of NO3s, and over here I see NO3. So I could actually treat the polyatomic ion as a single entity, as a group. So let's go ahead and try to balance this. Here I have 3 NH4s. Over here I only have 1, so I'm going to put a 3 here. Okay, now that's balanced on the NH4s. Now on the PO4s, here I see that I have only 1 PO4, 1 phosphorus and 4 oxygens, okay, but I only have 1 PO4, but over here I've got 4, so I need to put a 4 here. Okay, now that caused a problem, and I put the 3 here because now it's messed things up, because see, I've got 4 times 3 is 12, so I should have 12 here instead of 3, so I now have to fix that. Okay, so let's take that out. Alright, now we said that should be 12 because remember, in balancing chemical equations it's trial and error. So let's see if this is now balanced. Here I have 4 times 3 is 12 NH4s. Here I have 12 NH4s. Now here I have 4 PO4s, and over here I now have 4 PO4s. So far I'm balanced. Here I have 1 PB, here I have 3 PBs. So I need to put a 3 here. Now when I do that, that gives me 3 PBs, 3 PBs, and believe it or not, it gives me 3 times 4 is 12, 12 NO3s, and over here I have 12 NO3s. So believe it or not, we're already balanced. So the answer is 4, 3, 1, and 12. So I'll write them over here so we can actually keep up with them, because some people earlier was wanting to see how that actually played out with the other ones. Remember, we got 4, 3, 1, and 12. Okay, that's when we did it by hand. Now if you want to check your work using a calculator, using matrices, or if you just are lazy and you don't want to even fool with it, then you can just use a calculator. But remember, in order to use the calculator, which is in our case a TI-83, you need to make sure that you separate things up correctly. So draw lines straight down wherever you see plus signs, arrows, and finally at the end put lines straight down here as well. Okay, remember this is all by mouse, so my lines are crooked. Anyway, let me show you the problem that we run into. Notice that we have 1, 2, 3, 4 quantities, basically 2 reactants and 2 products. So we have 4 things. Well, if you've done this problem like we've done the others and listed single atoms, like here's nitrogen, over here is hydrogen. Okay. Next is phosphorus. I put a P here. And the next one that I would put would be oxygen. And then the next one that I would put would be PB. Notice that we run into a problem. Notice that the sacred rule of balancing these equations go out the window. meaning the largest that we can have is a 4 by 4 in this case, because we've got 4 quantities. So if you have 4 quantities, the most amount of rows you can have is 4 as well. But notice that we've got 1, 2, 3, 4, 5 things. Now that's bad, because you cannot work this with a TI-83 calculator. Now, you could if you had a TI-89 or a TI-92, but the 83s and the 84s, 85s, 86s cannot do it. But the 89s and 92s can. So, for practical reasons, we're going to have to look for an alternative, well, another way of doing this, okay, an alternate way. So the best thing for us to do is actually consider what we done earlier about treating the polyatomic ions as a group, basically a family. So that's what we're going to do here now. Okay, now watch this. Here, I want to treat NH4 as one entity. Okay, I'm going to write NH4 here. Then I'm going to treat PO4 as one entity. Now the reason why I can do this is both of these ions, the PO4 and the NH4, are on both sides. There's the NH4, here's the PO4. Okay, I'm going to also write down just regular PB here. The reason I have to do that here is because PB is on both sides. Okay, and finally the last one is the NO3. And look what we have here. We have a 4 by 4 now. So we had to do this just so that we could work the problem, okay? So we could basically make it a legal matrix for balancing chemical equations. So all you have to do is go down through here and number these. Here we have 3 NH4s. Here we have no NH4s, no NH4s, and here 1 NH4. PO4s here, 1. PO4 here, none. PO4 here, 4. That's funny. PO4, 4. Anyway, PO4 here, none. PB's here, none. PB's here, 1. PB's here, 3. Remember, I'm just looking at these, okay? There's 3 PB's, and there's 4 PO4s, and then there's no NH4s. Anyway, here PB's, I have none. None, yeah. And then here, NO3s, I have none, so 0. NO3s here, I have 4. And let's see. Here, NO3s, nope. And here, yes, 1. Now all we have to do is enter that into a matrix. Let's turn the calculator back on because it fell asleep. So we're going to enter these into our matrix. So we hit second, matrix. Going to move over to edit. And we're going to make this a 4 by 4. Okay, 4 by 4. Now we're just going to enter the numbers in. I have 3, 0, 0, 1, 1, 0, whoops, 4, whoops, made a boo-boo. Gotta pay attention. 4, 0, next 0, 1, 3, and 0, and finally my last one, 0, 4, 0, 1. Okay, after that, check all the ones that you've entered in. I've got 3, 1, 0, 0 in this column. Next column, 0, 0, 1, 4, 0, 0, 1, 4. Next column, 0, 4, 3, 0. And my last column, make sure it matches up, 1, 0, 0, 1. And it does. Okay. After that, back out of your matrix. Then go back to your matrix and choose the math column. Go to RREF, which stands for row reduced echelon form. Pick it. Go back into your matrix, and then select the A, which is the one that we edit. Press enter. Notice that we get some ugly, ugly, ugly decimals. That's okay. Decimals aren't so bad. We're going to hit the regular math key, the black one here. Choose fractions. Press enter. There that is. And look what we get. We get a nice, pretty fractions. Notice that the common denominator is between 3, 4, and 12 is 12. So I'm going to multiply this by 12 to clear my fractions. Notice I get the 4, the 3. See, there's the 4. There's the 3. The 1 here is negative. That's just to tell you it's on the other side of the arrow. Now, you see this last 0? You never write zeros, but look at the diagonal. 12, 12, 12, and there should be 12 here, but there's not, okay? But we're going to put the 12 here. So notice how that goes. That goes 4, 3, 1, and finally 12. Same thing that we got at the beginning. Just look at the calculator again. 4, 3, -1, just because it's on the other side of the arrow. Don't write -1, just put 1. And then the column of 12, you put 12 here. Now this 0, now if you were in a math class, that would mean something totally different. Okay? But in balancing chemical equations, you can do it this way. Alright, anyway, guys, I hope it was helpful, and just watch it several times. I'm sorry I had to go fast, but I want to get to bed tonight. Alright, guys, kind of tired. Alright, hope it helps, and watch it again and again.